Hello friends, I hope you are all doing great. Welcome back to my YouTube channel Void Loop Bytes and Automation. Today we are diving into a powerful concept from FreeRTOS. It is counting semaphore and how it helps synchronize the task and interrupt in embedded system. So let us get started. Counting semaphore is a synchronization tool used in FreeRTOS that allow multiple tasks to access a resource or run based on available count. Unlike a binary semaphore that allow only one access, a counting semaphore has a number of tokens. Each task takes one token when it starts and return it when finished. If no token are available, the task waits. This makes counting semaphore ideal for managing events, queues, or limited shared resources. This function is used to create a counting semaphore in FreeRTOS. First argument UXMax count is the maximum number of tokens the semaphore can hold. This is upper limit of token number. For example, if UXMax count is 5, then semaphore can never have more than 5 tokens. Okay. Second argument UX initial count is the starting number of token available when the semaphore is created. The task can take or consume token until the count becomes 0. For example, if it becomes 0, then task will block and wait state. Okay. Now let us see the Arduino programming. Before watching this video, you must watch previous lecture on binary semaphore. Check out the comment box for the link. This is previous lecture code on binary semaphore. We will edit in this code and test it. Okay. First of all, change the name of semaphore handle. It is X counting semaphore. So far so good. Now copy this handle and paste here to replace with X binary semaphore. Okay. Now change the function name X semaphore create counting and its argument I will keep 1 for max count and 0 for initial count. It means semaphore can hold only one token, just like binary semaphore. You can increase this number as per your requirement, and initial count semaphore means no task can proceed immediately because the starting count is 0. A task must wait until some other part of program gives the semaphore using X semaphore give function. Okay. Once given, the count becomes 0 and one waiting task can continue. After the task takes the semaphore, the count goes back to 0 again. There are 3 tasks, red, green and blue LED task with same priority 1. In red LED task, first need to give semaphore and change its parameter paste semaphore handle. Okay. You can keep X semaphore give function in any task function before while loop. Now change the argument of X semaphore take function with counting semaphore handle. It will take the semaphore here if it is available. If semaphore is available, then serial print will be executed. Then semaphore will be released using X semaphore give function. Change its argument with counting semaphore handle. Okay. Change this argument in all remaining task function. Now code is ready. To upload the code, go to tools, select the board related COM port, processor type and board. Now click on upload. Okay, code has been uploaded. Let us open the serial monitor. Wow, you can see strings are printing sequentially. Red LED task, green LED task and blue LED task. Okay. Alright friends, it was how to synchronize the task using counting semaphore. I hope you enjoyed this video and learned something valuable today. If you really found it helpful, please do like, subscribe and share. Thanks for watching. See you in next one.